Hi guys, today I have a very random video that was inspired by this comment because if you remembered, for the question 3 of the UNSW Integration B final, we changed this I1 into a double integral, but that comment said, can't we just let x to be tangent theta? And I thought that once we do that, the answer and the method and the answer will be very elegant and it will be very beautiful. So that's why I really wanted to create this video. So, like I said, he told us to let I1, so for I1, we let x to be tangent theta. So it's actually a trig sub. So why don't we do that? If we let x to be tangent theta, then dx will be sec squared theta d theta, and we can do the bounds. When x is 0, theta will be 0, and when x is 1, theta will be pi over 4, because tangent pi over 4 is 1. So now we can change I1 into the integral from 0 to pi over 4 of sine inverse of tangent theta. Now, 1 plus the square of tangent theta is actually a trig identity. And the answer to that is just sec squared theta. And then times sec squared theta d theta. And guess what? Cancel, cancel. So all we have left is from 0 to pi over 4 of sine inverse of tangent theta d theta. Okay, so now we can see that the integrand of I1 and the integrand of I2 are actually inverses, but they are only inverses on our domain. Okay, so how does this help? Well, if you watch one of my old videos, maybe a few months ago, then I've explained something like this. If we have the integral from a to b of f of x dx, and we add the integral from f of a to f of b of the inverse f inverse x dx, then this is just equal to bfb minus afa. Now, if you want to know the proof of this, then you can go watch my previous video. But in this video, I'm just going to use this formula. So, if you keep this in your head, then we see that I'm going to rewrite I. So I is 0 to pi 4 sine inverse of tangent, and then plus tangent inverse of sine. And you can just change the dummy variable to theta. So here we see that if this is A and if this is B, then we see if this function, sine inverse of tangent of 0, tangent of 0 is 0, and inverse sine of 0 is 0. So this is true. This equals to FA. Then, if this is B, tangent of pi over 4 is 1, sine inverse of 1 is pi over 2. So this is FB. So with that formula, we can just solve this in one go. BFB minus AFA. AFA is 0, so it's just BFB, which is pi squared over 8. So, this is another way to get this answer for the UNSW Integration B final, question 3. So, thank you guys so much for watching my video, and if you enjoyed my video and you want more videos like this, please consider liking and subscribing. If you want to master something, teach it.